Welcome to this overview of Infrahub by OpsMill. We're super excited to share more with you today about Infrahub, give you some more details and a demo walkthrough. So let me just quickly introduce the speakers. Pete Crocker is the Director of Solution Architecture, and Wim van Duin, who is the Senior Solution Engineer, will be leading us today. So with that, I'm going to hand things over to Pete, and let's get going.
Thanks, Alex. Welcome, everyone. About 7 years ago, one of our founders, Damien Garros, began thinking about how to solve some of the fundamental challenges he saw with organizations developing and maintaining infrastructure automation. 18 months ago, he partnered with Raphael Monnier, a longtime leader in networking and security companies and a previous startup founder. Raphael had faced the same challenges at a previous startup and had to build his own painful and costly automation stack. A year ago, they launched our company, OpsMill. And over that last year, a team of automation experts has been building Infrahub. 2 weeks ago, Infrahub was released on GitHub, and today we're proud to show it to you. We're going to cover an overview of Infrahub, the industry's first infrastructure automation platform that delivers a source of truth with extendable schema, versioning, and native continuous integration capabilities. Then we'll move to a live demo and finish with time for any questions. Let's get started. Back in March, EMA Research ran a webinar about the current state of network automation. If you're joining this webinar, you've most likely made significant investments in your automation journey. And after all that investment, you think that most teams would be pretty happy with how things are going. But it turns out that's not to be the case. EMA Research found a lot of dissatisfaction. For example, only 20% of those surveyed were happy with their source of truth, which is the centerpiece of an infrastructure automation tech stack. Why? Well, their research uncovered that these teams were stitching together a Frankenstack of open source and commercial point tools to build their automation. And that leads to a lot of complexity, fragility, tech debt, sleepless nights, and things that break when you least can afford them to. Sound familiar? So the question is, why is it hard work to maintain a homegrown automation stack? Let's talk about how your automation initiatives should have gone. You set out with modest goals, quick wins, low-hanging fruit, so far so good. You wrote an Ansible playbook, yay! You spun up a source of truth, great! But then you started seeing how hard it was to build something for more than just yourself or a small team of automation experts. You didn't sign up for an exponential investment in automation tooling and maintenance. The goal for automation was reliability, efficiency, and responsiveness to your organization. What you needed was a platform to scale out the value of automation without the complexity and fragility of having to build and maintain it. What you got was your experts just trying to keep the stack working when you needed it most. The first challenge to a successful automation journey is data management. It's the fragmentation of data, tools, and vendors, leading to a lack of a central hub of information. Information such as the data, processes, configuration files, and automation code are fragmented across different tools and different teams in different formats between vendors. Business logic and data are in different places, necessitating messy integrations. The result? Routine maintenance and updates take longer than they should. There's a lack of visibility, traceability, and compliance. And teams lack visibility and access to quickly troubleshoot, make decisions, or plan and model impacts for new projects. The reason is all those point tools miss out some key elements. Pretty much every infrastructure source of truth or database you get comes with a fixed schema. Need to evolve your data model? Get ready to slap some things on the side. Infrastructure management tools were generally built without versioning, collaboration, or CI validations in mind. They expect you to add them. You need them, so now you have to build and maintain even more integrations. Most integrations create complex and fairly opaque dependencies that are hard to validate. For example, if you pull data out of your source of truth into a deployment tool, the rendered data is embedded with business logic. If you need to change your data model, figuring out how that will impact the deployment process is extremely difficult. Give this Frankenstack a few turns of the clock, and you start creating a pretty painful load of tech debt. These problems are exactly what Infrahub was designed to solve. Infrahub goes beyond being just a source of truth because it includes some key elements that allow you to build a sound, sustainable automation process without all the stitching together and tech debt of homegrown integrations. We're bringing the world of infrastructure data and GitOps together in a single platform with an extensible data model, versioning, artifact rendering, and CI validation, so network and infrastructure teams can build a reliable and sustainable automation for the long haul. Imagine if you needed to recreate your infrastructure from scratch overnight. What would be needed? It's not just the data such as devices, it's the model, the data, the code, the templates, plus a reliable method to generate and deploy changes. This is what Infrahub is. Before we jump into how Infrahub works, let's talk about Infrahub's role in the overall automation framework. Infrahub is the unified source of data and files that power the infrastructure. It can pull in information from other sources, allowing a central repository for teams and tools to understand the infrastructure. For configuration deployment, Infrahub integrates with existing tools and workflows to implement changes. And as a unified source of truth, it can be used to keep monitoring and observability stacks up to date with their inventory and needed infrastructure-specific configuration. If you're using a higher-level orchestrator, Infrahub can be orchestrated as part of a larger workflow as needed. So now let's talk about how we do it. First, let's dive into how Infrahub solves the first key pillar, an extensible model. Data management is a fundamental challenge in many organizations. Once the data is organized and accessible, you can then build trust, which leads to reliable automation. Every organization has slightly different requirements, and the requirements change over time. Adaptability is paramount. Git-based approaches allow for infinite flexibility, but come at the cost of losing relationships in the data and interfaces such as a web UI or API to interact with that data. Infrahub is built on the power of a graph database, but with a schema layer to make it straightforward to extend and maintain. No need for database wizardry. Infrahub abstracts the interaction with the underlying database. This model or schema allows an organization to define their infrastructure according to their needs. Because it's easily extensible, it also means that you can start small and adapt or expand over time. No need to worry about getting it perfect on day one, as making changes are as easy as making a device change. For those of you familiar with existing sources of truth, you'll know that modeling things like MLAG or DMVPNs is tough, much less trying to model something more complex like optical infrastructure, cloud, or Kubernetes. These are examples of what an extensible schema provides. Having a flexible schema opens up new possibilities not previously available. Many of our current deployments are being led by design-driven automation goals. Infrastructure is more than just the physical devices and protocols. It's there to serve the needs of the organization. In the past, a senior engineer would design a new network or service, document it, and create the first implementation. Once the first design was done, they'd effectively created a historical document. If they needed to iterate on the design, it would all be done manually. However, what the business wants is reliability, efficiency, and responsiveness. Making modifications to a design to be responsive to the business creates manual changes, tech debt, and risk. Infrahub allows a business workflow or service to be implemented in the model, linked to the current implementations of the design, and all the way through to the device level configs. If a business service needs updating or expansion, all needed changes can be generated to keep the infrastructure consistent and validated. This is built on an Infrahub concept called generators. Generators automatically create the building block objects necessary to instantiate the design, keep them linked to the design so they can evolve over time. One of the most common use cases we've already seen is automation teams building out a service catalog of common changes to allow adjacent teams to safely request new services to be defined on the infrastructure. App team wants to add a firewall rule or VIP? Great, create a generator for this workflow. The second pillar is version control. Peer review and validation are at the heart of many teams' workflows. Infrahub has recreated Git-like concepts such as branch, diff, and merge on top of the graph database to give the best of both worlds. This allows for teams to create a branch for future planned changes, assign a colleague to review the changes, and merge the change once it's been deployed to the production infrastructure. Infrahub also maintains an immutable historical view of the network, allowing transparency and auditing of changes over time and making troubleshooting easier. Underpinning this, one example is a feature called Resource Manager, allowing for the allocation of resources such as IP addresses to be done for not only existing infrastructure, but also future planned changes. Let's use a more advanced example to show the challenges Infrahub is designed to solve. Imagine you'd like to add SD-WAN onto your infrastructure. First, you'd need to extend the schema with a model of how SD-WAN works. Then you'd need to add data defining the devices. Finally, you may need to define a new vendor-specific template to generate configurations. All of this can be done in a branch in Infrahub. Let's now talk about the other features needed to actually complete that workflow. Transformations are a key feature of Infrahub, allowing for the pulling of relevant data from the database and rendering that data in a structured manner. The most obvious use case is generation of device-specific configurations. Create a branch, make a change to the data associated with some devices, and Infrahub will generate new device-specific configurations using things like Python or Jinja 2. The output of a transformation is called an artifact, and Infrahub can generate artifacts in just about any format. Flat files for vendors that want CLI commands pushed, XML or JSON, for example. And artifacts aren't just limited to device configurations. You could generate documentation or update the inventory config needed by an observability platform, for example. Finally, a key point is that transformations will only generate new artifacts based on what's changed, making this scalable and efficient in large environments. An example use of Infrahub's implementation of transformations would be vendor swap-outs. Infrahub could generate artifacts for both the old vendor and the new vendor simultaneously, allowing for testing and simplified migrations. Third pillar is a CI pipeline. In the world of code, we usually validate every unit test for every change just to be sure. This makes it difficult to deploy incremental infrastructure changes quickly. In addition, when we've seen organizations implement CI pipelines for infrastructure, they're cobbling together information from many different places, leading to fragility and time spent on just keeping it working. Infrahub has a built-in CI pipeline allowing for validation. We want to ensure that all of the relevant data, schema, and templates are checked in a branch for each change, no matter how simple or complex. Building in a CI pipeline natively allows Infrahub to understand what's changed and only regenerate artifacts and run checks on the subset of the overall infrastructure impacted.
This leads to a much more scalable and efficient change process. No more waiting for thousands of unrelated, unmodified devices to be checked by a playbook run. Finally, no platform stands on its own. There's rarely one source of truth. There's existing tools and frameworks being used for deployment. Infrahub must fit into this existing ecosystem. To understand this, let's talk about the 4 domains to manage infrastructure. First, design. We've talked about design-driven automation and flexible schemas previously, so let's focus on build and deploy. Build. Infrahub needs to unidirectionally or bidirectionally sync with other data sources, such as ServiceNow CMDB, internal OSS or BSS systems, and existing tools like Netbox. This can be done via Infrahub Sync, a maintainable way to integrate with other systems. Deploy. As we discussed previously, the built-in CI pipeline will generate configuration artifacts. Today, Infrahub provides solutions for the design and build phases, and we seamlessly integrate with tools for deployment. We've published examples of how to use tools such as Ansible and Nornir to deploy configs, and soon we'll provide other examples such as Terraform and NSO. And the last phase, operate. Infrahub Sync can be used with tools that gather actual state data to reconcile the inevitable drift from intention to deployment. Let's see this in practice through a few use cases we're building in partnership with our first customers. The first is a unified source of truth. Combining Infrahub's extensible schema, metadata, and sync allows the consolidation of infrastructure and business data in one central place. This allows for role-based access via web UI and API for all the teams and tools that rely on this data. The next example is how you get from a small group of automation experts to organization-wide adoption of automation. The first most obvious step in this is vendor-agnostic configuration and deployment. Using versioning, transformations, and the CI pipeline allows for multiple people and projects to automate simultaneously. For example, dealing with hardware refreshes, vendor swap-outs, and future plan changes are all done in a validated and automated manner. And the third use case is around design-driven automation. The most common example is the creation of a service catalog for other teams in the organization to request and self-service their needs on the infrastructure. This is about scaling the value of automation from a small team while de-risking change and providing compliance and auditability along the way. Server team wants to add a VLAN? Create this service so they can request and even safely implement low-risk changes themselves. Need to add a new branch site or VPN? Or take a more involved change, such as security policy around a multi-cloud deployment, where information about both the cloud and the on-prem infrastructure is affected. We've got a growing list of examples we're developing, and these are being shared with and built by our community for everyone to benefit from. Now, it's demo time. I'm going to hand it over to Wim, who's going to show you Infrahub in action.
All right, thank you, Pete. So today we will be taking you through the Infrahub platform. I'm going to do that by showing you how you can make a change to an existing network in Infrahub. In the first phase of this demo, we will do this change manually, and I will take you through the process of how to do it manually within Infrahub up to the point where we can merge a change back into main and deploy the configuration artifacts to devices. In the second phase of the demo, we will abstract that workflow into a service where we will take a design-driven approach. So we will be creating a service instance and then leverage Infrahab's generator feature to create all of the downstream or lower-level implementation objects that we need to fulfill the service, and then show you how we can get to the generated configuration artifacts for the devices as well. The change that we will be making today is adding a backbone link to an existing network that we have already modeled in Infrahub. All of the models that you see, for example, on the screen, you are seeing a list of devices, are all created using our flexible schema. All of the models that we will be using throughout this demo are available in our repository. They are there as an example for you to see what a schema could look like. But it also allows you to be a foundation to build your own schema. Or, if you don't like the schema, you can create one yourself. But everything is completely fixable. That's the main point. Also, the menu on the left that you see is generated based on that schema. So if you change your schema, then this menu here on the left will be completely different. All right, let's start making our change. So the first thing that we will have to do in Infrahub is create a new branch, which is going to create an isolated environment in which we can make our changes without affecting the main branch. So we'll be making a branch called change manual. This is an extremely lightweight operation. As you can see, the branch was created immediately. In the backend, we are not copying data or those kind of tricks. It's a branch is exactly what you are familiar with from Git. And you can have multiple branches simultaneously within the system. So we have created our branch and we can now start to make changes. The first thing we will do is create a new circuit, which is going to be the foundation of the new backbone link. We will provide a circuit ID. For us, this is going to be an internal circuit ID that we use within our organization. We will have to provide a provider ID for the circuit. We are going to assign it a status, a role, and we will create a relation to the provider of the circuit, which is Lumen in this case. So we have created the object now. It shows here in the list of available circuits in the database. If I switch back to my main branch, you will see that that circuit does not yet exist in the main branch. So let's navigate back to the branch where we are making the changes, and you will see that the circuit pops up again. The next thing that we will have to do is connect the interfaces, the circuit to the interfaces that will host the connection on the network devices. To do that, in our data model, we will have to create what we call circuit endpoints, which allow us to connect a circuit object to interfaces on the device. I could do that in the UI, but it would take me some time to do that. And I don't think that's particularly interesting. So it allows us to showcase another feature within Infrahub, which is the GraphQL API. The GraphQL API is an API that we expose to our users, which allow you to make all of the changes to the data in Infrahub. The queries and mutations that the GraphQL API expose are, again, dynamically generated based on the schema that you load into the system. So if you provide your own schema, you will have completely customized GraphQL API mutations and queries. In this particular mutation that I'm showing on the screen, we are going to create two circuit endpoints. The first mutation is going to link my circuit to a endpoint, which is the ID of an interface on a device in the Atlanta site. And then the other end of the circuit will be connected to an interface on a device in the Denver site. Notice that this GraphQL query or mutation is going to be executed within the branch as well. I have an issue here.
Beauty of doing a live demo.
Okay, let me quickly fix this. I'm sorry.
That's fine. You want to take a minute and sort that out. I saw there were a few questions, so I can try and answer one of these here along the way. One of the questions it was around how Infrahub's going to be released. It's available today. It's open source, and after Wim finishes the demo, I'll actually talk to a bit more detail about that.
Yeah, I think I should be ready, Pete.
Go for it.
All right, so I'm going to execute my mutation in the branch. So I've now created the circuit endpoints that connect our circuits to the interfaces on both ends of the circuit. So I can now go back to my circuit in the database. We can now see there's 2 endpoints for this circuit, and we can navigate to them. So one of them is going to take me to interface Ethernet 7 on the device Atlanta 1H1. And we can see that it's connected to the circuit below. We're going to make additional changes to this interface. For example, we're going to set the role of the interface to backbone, and we will be assigning an IP address to this interface. All right, then we are going to navigate to the other end of the circuit, which is in Denver Ethernet 7 on device Denver 1H1. We're going to make the same changes. So we will be assigning the role backbone, and we will be adding an IP address on this interface. All right. So now basically our change is done from a source of truth perspective, from a data perspective. We are ready to propose this as a change to the rest of our organization and start the process to merge this change into the main branch. In Infrahub, we can do that using a feature that we call proposed changes. Proposed changes are very similar to the GitHub pull request process. So it basically is going to ask you to provide the branch that you want to merge back into main and allow you to add some additional contextual data, like a title. So let's name this one add platform link. We can add more description about the change and even select the list of people that are supposed to review this change. We're not going to do that in this demo though. So create the proposed change. Within the first few of the proposed change, you get some details about which branch you are merging and some more other contextual data. But you could also start to have a conversation with the rest of the team surrounding this change. For example, let's post a quick message that the change looks good to us. So we could have a complete conversation here. On the data tab, we will start to see what has changed in the database from a data perspective between the 2 branches. So we effectively get a diff view from the data point of view. So what you can see here is that Infrahub is telling us that in this branch, we added a circuit with particular attributes and relationships. We will also see that we added the circuit endpoints that we created using the GraphQL API, as well as the changes we did in the UI for the interfaces. As Pete mentioned throughout the slides, Infrahub also has a feature called transformations, which allow you to change the data in Infrahub to some other output format. In this particular case, we have used transformations to generate a configuration artifact for our devices. If we expand on them, we can basically see how the data changes have affected our configurations. So the configurations have been regenerated based on the data that was changed in the database. And we can see that the intended configuration of Ethernet 7 has now changed. We basically added the description that this interface is of role backbone. We add the IP address to the interface. We configure it to be a layer 3 interface, and we add it as a point-to-point link to OSPF. the same change has happened for the other device. So these are Jinja2 transformations that we used in this particular case, but we can also use Python transformations to generate other types of artifacts. In this particular case, we use a Python transformation to generate an open-config payload, which is the equivalent of the text change that we did above. Notice that within this proposed change, you will only see artifact updates for the devices that were affected by the data changes. We do not regenerate the configurations for devices for which we don't need to regenerate it because the data was not modified for them. Then, as part of this proposed change, we also ran a CI pipeline. In this particular change, we ran a few tests. The first test that the system has run for us is a data integrity test. It is checking basically that there is no data conflicts or merge conflicts that we created within our branch. We also have artifact validators that are basically going to validate which artifacts need to be regenerated and whether or not we can generate those artifacts successfully. If those artifacts would fail to properly be generated, then the pull request or the proposed change would be blocked from being merged. Finally, we also allow you to provide user-defined tests or checks. In this case, we have added a check to Infrahub, which is basically going to check that every site within the database has enough redundancy to the backbone network, redundant connectivity to the backbone network. It's basically a business rule that we need to have some level of redundancy. If you make changes to the database that would break that rule, then we would block the proposed change from being merged. So that concludes the change. We have gone through the proposed change. Everything looks good. We can now merge this change back into main. So if I now go to my main branch, you will see that the, for example, the circuit object now exists within main. It is connected to the two endpoints, which are interfaces on the devices, and they have the correct configuration and the IP addresses have been assigned to them. Great. So now we could consider this to be a fairly standard change in our network, and we could say that we want to allow other people to make these changes, and maybe those people are not that network or are not that skilled in networking, so we want to expose it as a service to them. So within Infrahub, we can do that by using the generators feature. So the first thing we have done is created a model in which we can basically model this as a service. First thing I'm going to do though is again creating a branch because I'm going to make changes to the database. Let's always change generator. So we created a new branch, and the first thing we are going to do is create a new instance of a service object that represents the service that we want to implement. I called it the backbone service. This backbone service is going to ask the user or the consumer of that service to give us some input details, like the circuit's ID. So let's give it a circuit ID. Let's give it an internal circuit ID. Let's give it a name. Backbone, the provider of the circuit that is going to make up this service. The first site which we want to connect using this circuit, let's take Denver 1, and the second site, which is going to be TFW1. So we created the service instance. We need to add it to the service instance group. So let's add it to the backbone services group here. That's it. So now basically we have added the service instance, and we need to create a proposed change. Change. Let's create a new one. We will pick change generator branch, and we will give it a name. And we will create our proposed change. So now in this proposed change process, the generator is going to run. And we can already see that it is in progress here. So basically what it is going to do is going to pick up any new service instances that have been created within Infrahub and pass those onto the generator. The generator will then basically create all of the downstream objects following the business logic that you provided according to your design. Let me refresh the screen to see if it has already finished. It already finished. So let me take you through the proposed change again. We see the overview of the data that is being provided around the proposed change. On the data tab, we will start to see the changes that have been made by this generator. You can see that, first of all, we created the backbone service object, and then all of the other changes are basically done by the generator itself. You can see here that we created a circuit called TUF5678 with particular attributes and relationships. We can see that the generator has allocated a new prefix that will be assigned to the circuit. It has assigned IP addresses out of that prefix that we are going to use for the interfaces that are going to be connected to the circuit. And then we will see that it has used a business logic to allocate the right service. Use a business logic to allocate the right interface that should be connected to our service and has assigned an IP address to it. So if we now go to the artifacts tab, we can already see that again, the artifacts have been updated for the devices that were affected by this change. So in this particular case, we can see that Ethernet 3 was modified. The IP address that we saw in the data change has been assigned to this interface. We convert the port to the layer 3 interface, and it has been added to OSPF. The same thing happens for the other end of the circuit, which is the interface on Ethernet 3 on the TFW side. And then we also generated the same open configuration again. The CI pipeline has run, basically validating that all of our changes look good. We didn't create any conflicts. The backbone service generator has run and created all of its objects. We have successfully regenerated our artifacts, and the user-defined check for the backbone link redundancy has succeeded. So again, we are ready to merge that change back into main. Now, if you would need to start lifecycling this object, it is very important that we can track which objects that service is responsible for. And we can basically quickly do that by going to the groups in Infrahub, and I can quickly identify the group that was created because of the generator that run for our service instance. And within that group, we can now see that all of the objects that our generator has run have been gathered into a group. And this is a way for us to start tracking basically all of the objects that this service instance is responsible for. So we can now basically start to do changes to the service, and then our generator will know which objects we need to touch because of that change. All right, that kind of concludes the demo for today. So I'll pass the ball back to Pete.
So OpsMill believes in the value of the open source automation community. Much of the work that we've done in our past lives has been built on open source tools.
So we've already released the open source offering of Infrahub out on GitHub, and we're actively building a community around it to help share the knowledge and examples that we've been creating. In addition, later this year, we'll have a production-ready and scalable product, a commercial model, plus systems and support necessary to have a solid enterprise offering. We'd be happy to talk about more details about that with you. We're also currently building out a cloud SaaS offering and deployment of Infrahub in various cloud marketplaces for both the customers who prefer a fully managed offering and to make it easier for prospective users to try Infrahub with rapid time to value. These are options, of course, compared to spinning it up locally. And let's go ahead and actually talk about those options here next. So how can you get started with Infrahub here today? So you can spin up Infrahub in just a few minutes right now by going to our GitHub repository, clicking on a single button, and using GitHub code spaces. GitHub allows you to essentially spin up an instance of Infrahub and give you access to the web interface and API, and gives you free credits so that you can go through our documentation. And we've got a great getting started tutorial to walk you through the basics of how Infrahub works. Or alternately, you can spin up an instance locally on your laptop or a server via Docker and Kubernetes. We've made this one line simple to be able to spin this up with some demo data sets so that you can get some hands-on. And as a few other paths, no system stands on its own, so we have Infrahub Sync there to bring in data from other systems and sources of truth. There's a repository for that. And Infrahub is built as a platform that's made to be integrated with. So we've published out Python SDKs and APIs with extensive documentation here from day one. In addition, we've got experimental tools for quickly building and extending schemas, and we'd be happy to partner with you on developing Infrahub in your environment, so please reach out.